Hello everyone. In this session, we are going to understand the transient response of a series RL circuit using MATLAB Simscape. I will explain everything step by step in simple way. In this video, we will do three things. First of all, we have to build the RL circuit in Simscape. Second, we need to apply a step input. And third, we are going to analyze the output waveform, and by the end of this video you will clearly understand both simulation as well as theory behind this topic. First of all, let us understand the circuit. Okay, this is a series RL circuit. Here we will be having a resistor of 100 ohm and then inductor of 20 millihenry, and a DC source is placed and are connected in series, and we are also measuring the voltage across the resistor. Okay, this is the resistor. We are measuring the voltage across the resistor using voltage sensor block. Similarly, we are measuring the voltage across the inductor with the help of the same voltage sensor block. These signals are sent to the scope. Okay, this is sent to the scope. This is the response of the inductor and this is the response of resistor, can be seen in this scope, and on comparing both the response we can see this in a special scope which is RL response. Let's directly construct the Simscape circuit. Okay, this is the MATLAB window. Here just click on this new button, just click on this home button and then click new Simulink model. And once you click it, here you have to select the create model. Under blank model, just click on create model. Okay, the file is created and here we need to save the file initially. Just Ctrl+S, or you can click on this save button under simulation tab. Downloads, I am saving. Use proper name for file. Here I am using the name as RL Transient. Save. Here we need the component list. First we need controlled voltage source. Controlled voltage source from foundation library, the first one. Second one, resistor from foundation library, and then inductor, you can rotate inductor like this. Accordingly you can place the component. And then voltage sensor we need. Voltage sensor block once again from foundation library. You can search the component by clicking on any empty space, that is by clicking on left click. Okay, you should use the left click on your mouse on any empty space and you can choose voltage sensor block. Once again you have to connect it across R and L, and here we need step input block. Okay, this step input block is a Simulink block, so we need to communicate to the power system component block with the help of Simulink to PS converter. Okay, you have to use Simulink to PS converter. You have to communicate Simulink component with this power system component. Okay, blue color are power system components, the black colors are Simulink components. And then solver configuration. You have to include solver configuration. And then electrical reference, you have to add. Once again, we need scope button. Okay, this is the general scope. Here I am going to combine two signals. For that I am using mux block. Here I am going to combine two signals. Now to compare the response, R response as well as L response, I am using the mux block. And once again, here these two are Simulink components and this is power system components. Now to convert this power system signal to Simulink, I need PS to Simulink converter. Okay, PS to Simulink converter I have to use. And here also I need a PS to Simulink converter. Now we can connect this positive to positive, this positive to negative, and this negative to this negative. You have to connect. Once again, you can connect this. Solver configuration here, and this electrical reference here. With this you have to connect, and then once again step input, you have to connect it here, and this Simulink to PS converter to be connected to this DC source. We can make it as DC source. Okay, we can make it as DC source, and this is 100 ohm resistor. We are using 100 ohm, and this one is a 20 millihenry inductor. Okay, these are the values. You can also format this. You can bold this elements by clicking on this format block, format tab. You can format, and once again I have to measure the voltage across the resistor, so I have to connect like this, and this is to connect this. So we have to connect this. Once again you have to connect the voltage sensor across this inductor. And this to this side. Okay, this is the actual. Okay, here we can make it as R response. Okay, just name it as R response. Here we can make this is to Simulink converter as L response. You can keep it as L response. Now our circuit is ready. We can keep it like this. And you can have the name, you can give the name of the circuit. So you have to give the name, but add notation. You can select and increase the font size, keep it red color, dark red, black color, and then I have bold. Now it is ready. the transient response of series RL circuit using Simscape. Now we need to set the values. Okay, for resistor we need to set the values. Which is 100 ohm, 100 you have to represent. Then for inductor we need to set the values 20 millihenry, 20 into 10 power minus 3, 20 e power minus 3 you have to represent. And for step, here we are using the step block, that is step input, where we need to have some settings. That is step time is 0.01 seconds, initial value is 0, final value is 1. Okay, this means before 0.01 second the circuit is off, whereas after 0.01 second the circuit turns on suddenly. Okay, that is the meaning. And why we are using step input is, here we use step input to study the transient behavior, which means how the circuit reacts when voltage is suddenly applied. Okay, that is the main reason we are using the step input in this circuit response. Also we have some circuit. Just click on this OK, and then also we have some theory behind. Okay, we know the derivation, that is the transient current expression I of t is equal to V divided by R into 1 minus e power minus t by tau, where tau represents L divided by R. Okay, and the inductance value divided by resistance value. Here in our case L is 20 millihenry, which is 0.02 henry, the R is 100 ohm. Okay, from that we can find the tau value, which is 0.0002 seconds. This is very small value, so the response will be very quick. Okay, compared to, which is based on the values of L and R. Okay, that is very important. Coming to the circuit, okay, this is a circuit we have constructed. This is the final circuit we have constructed. And now go to simulation tab, and here you can set the simulation time as 0.025 seconds. Okay, any value you can set. Here I have made it as 0.02 seconds. And let's run the simulation and observe the output. Just click on this run button. And just double click on this scope. And here you can have some settings. Just click on the settings. Here under display, just click on display. Here edit the display as RL response and show legends. Just neglect this show grid, and then just click on this axis title. Here axis background you can select it as white, and this one as black. Axis background, and this background as, once again, any color relevant to white or light color you can choose, or you can keep it as it is. Here line, for our response we have taken this dark line, you can keep it as 4. Okay, you can also make it as red color, whereas you can choose this inductor you can keep it as, you can choose different line. Okay, dotted line I am choosing, and then also you can choose 4. So the blue you can keep it as black. Your setting is over. Just close the tab. Now it is showing the grid, that is the axis values, as well as here you can make it as the fit to the screen. Okay, here the top right corner you have the options where you can choose this to fit the response to the screen, and then all response. Here we can have the legends, okay, RN response, and this here the red curve, okay, the red curve is the resistance curve, which represents the resistor voltage. It starts from 0 and gradually it increases to maximum value. Okay, it increases and it settles at the maximum value. Whereas this black color curve represents inductor value. Okay, this black color curve represents inductor voltage. At the starting point it is very high. Okay, at the starting point it is very high. It looks very high, and then it quickly reduces to 0. Okay, this is the inference behind this RL response. Okay, and the inductor behaves like an open circuit. Okay, at the instant of switching. Okay, so the current is 0 and the voltage appears across inductor. Whereas during transient, the current starts increasing slowly and the energy is stored in a magnetic field. Okay, whereas at steady state condition, the inductor behaves like a short circuit. So voltage across inductor becomes almost 0. Okay, you can see this. It is almost becomes 0 and current becomes maximum. Okay, here there is no current waveform, there is a voltage waveform. If you want, you can compare the current waveform also. Okay, and this is about this transient response of this series RL circuit. And we see let's summarize this video by having some key points. That is, here the RL circuit gives exponential response. The inductor opposes sudden changes. Okay, and the time constant controls speed. Also the voltage shifts from L to R. Okay, in this video we understood both simulation as well as theory of RL transient response using MATLAB Simscape. Thank you.